Most C++ bugs don't come from what you write. They come from what you misunderstand, and nothing causes more silent errors than confusing pointers and references. Today I'll show you exactly why that difference matters with real code that breaks if you get it wrong. Hey everyone, welcome back. In today's video we are diving deep into a topic that every C++ programmer must understand: the difference between pointers and references, and why this difference actually matters in real-world code. Let's start with the basics. What is a pointer? A pointer in C++ is a variable that holds the memory address of another variable. That's its entire job, to point to a memory location. You declare a pointer using the asterisk symbol, for example like this. Here ptr is a pointer to an integer, and it's holding the address of x. Now, a reference is a bit different. A reference is basically an alias for another variable. Once it's set to refer to a variable, it cannot be changed to refer to another. You can use the ampersand to declare a reference, but the usage is a bit different from when you are getting an address. Now, ref is just another name for x. If you change ref, you are changing x, and vice versa. So far so good. But now comes the part that trips people up. Why do we have both? And what should we use when? Let's break this down step by step. One of the first differences is that references must be initialized when they are declared. Pointers do not have this requirement. This means you can't just declare a reference and assign it later. That ensures more safety and predictability with references. Pointers can be null, references cannot. This is a key difference. If you try to simulate a null reference using a pointer dereference like that, you're entering dangerous territory. This is one reason why references are considered safer when you know the variable will always exist. Pointers can be reassigned to point to something else. References can't. In the last line, where we write ref equals b, the program does not rebind the reference. It assigns the value of b to a. This distinction is subtle but very important. Pointers can make your syntax noisy. If you have a pointer, you need to use ampersand to dereference it, or an arrow operator to access members. With a reference, it's cleaner. You just use it like a normal variable. So when you want to pass around objects and avoid copying, references are usually cleaner and safer, especially for function arguments. Let's talk about functions. You can pass arguments by pointer, by reference, or by value. Passing by pointer makes it clear that the argument might be null. But if you know the argument will always exist, passing by reference is better. This version is shorter, safer, and communicates the intent clearly. You're telling the caller, I need this variable, and I will modify it. And if you're not modifying it, just use a const reference. This avoids unnecessary copies while still making it clear that str won't be changed. You need pointers when you deal with dynamic memory using new and delete. References can't be reseated, so they are useless in this context. You can't write int reference equals new int. That doesn't make sense in C++. However, in modern C++, we usually avoid row new and use unique pointer or shared pointer instead, but that's a whole other video. Pointers can do pointer arithmetic. References cannot. This is sometimes necessary when working with low-level data structures or interfacing with C code, but it's also a source of many bugs. Buffer overflows, invalid accesses, etc. References don't allow this, which again makes them safer. Const plays nicely with references. You can use a const reference to bind to temporary objects. You can't bind a non-const reference to a temporary. This is a great way to write efficient functions that avoid copies while staying safe. If you need to simulate optional arguments or outputs, pointers make more sense. You can't return results via references here unless you're certain the argument is valid. If you've ever written a class with overloaded operators, you've probably seen code like this. That's a reference return type. This allows chaining. Returning by reference avoids unnecessary copies and allows that fluent style. Pointers wouldn't work here because they imply potential nullness and dereferencing. References communicate that the object is guaranteed to exist. Let's recap the major differences. References must be initialized immediately. Pointers can be null, references cannot. Pointers can be reassigned, references can be reseated. References are syntactically cleaner. Use references when you want safety and clarity. Use pointers when you need dynamic memory, optional values, or indirection. References feel like aliases. Pointers feel like tools for managing memory and lifetimes. So why does this all matter? Because choosing the right tool for the job leads to clearer, safer, and more maintainable code. References help you express intent, like saying, "This thing must exist and I'm just using it." Pointers help when you say, "This might be optional" or "I'm managing its lifetime." And in large code bases, clarity is everything. It helps your teammates, your future self, and the compiler understand what you meant. So next time you write a function, pause for a second. Do you need to manage memory? Use a pointer. Is the object guaranteed to exist? Use a reference. Want to pass something without copying? Use a const reference. These little choices add up to code that's clean, safe, and elegant. Thanks for watching. If this helped clarify things for you, give the video a like, subscribe, and check out the playlist on the screen. See you in the next one.